derivatives of function in parametric form. What happens? Sometimes the relation between two variables is neither explicit nor implicit, but there is a link to a third variable. With each of these two variables separately, they are establishing a relation between these first two variables. Means A and B are there, they are not related together, but A is related to T and B is related to T. In this kind of situation, we say that the relation between them is expressed via third variable, and this third variable is nothing but parameter. We call them as a parameter. So we need to make more precise that relation expressed between two variables x and y in the form x is equal to ft, y is equal to gt. This is said to be a parametric form with t as a parameter. So in order to find the derivative of function, we can use the chain rule. So dy by dt we have seen in chain rule will be dy by dx dot dx by dt, because this cancels, it will give you dy by dt. So dy by dx can be written like this. This can be taken in the denominator. So this is dy by dt and this is dx by dt. Again, you get the same stuff. You are actually dividing here by dt. Now this dy by dx can be written as this, and this is nothing but dy by dt is g dash t. If you assume that this dy by dt to be g dash t, because this is gt, y is gt, then y dash is g dash t, which is nothing but dy by dt. Here also, this one, here it is called f dash t. So dx by dt. This should not be 0. Let us take an example. We have dy by dx. We need to find x is a cos theta, y is a sin theta. So what we will do, we will find dx by d theta and dy by d theta, and then we will divide both results. So x is equal to a cos theta, dx by d theta will be what? A cos theta is minus sin theta. And this dy by d theta is what? A sin theta is cos theta. Now we need to divide this by this, because we want dy by dx. When we divide, we get minus cot theta. Find dy by dx if x is equal to at square, y is equal to 2at. So we will find dx by dt and dy by dt, and we will divide dy by dt with dx by dt. So x is at square, y is 2at, 2 into a into t. So dx by dt will be 2at, means a is constant, differential of t square is 2t. Here also, this is constant, so differential will be 2a. Differentiation of t with respect to t is 1 only. So when we divide this by this, we get 2a by 2at, and this is nothing but 1 by t. Find dy by dx if x is this and y is this. Again we will differentiate with respect to t, or here we will have theta, so we will differentiate with respect to theta. So dx by d theta is what? A 1 plus cos theta, because theta is 1, this a will be outside. Theta is 1 and cos theta is sin theta is cos theta, differential. Again a will come here, 1 will be 0 and minus cos theta. Cos theta is minus sin theta, so minus cancels out. It will be a sin theta. When you divide these two, divide by d theta by dx by d theta, we get this. That is a sin theta by a 1 plus cos theta. But how this has come? This sin theta can be written as 2 sin theta by 2 cos theta by 2. And this 1 plus cos theta can be written as 2 cos square theta by 2. 2 cos square theta by 2. This cancels. Sin by cos theta by 2 is tan theta by 2. We want to find dy by dx if this is the power. So, how to do this? We will use the parametric condition only, but here let us put x something or y something, so that we get, or we can just eliminate this powers, and we can get a straight kind of equation, so that we may solve it. So we can put x equal to a cos cube theta, y equal to a sin cube theta, because x cube 1/3 is x only. That is why we have placed a cos cube theta and a sin cube theta, because we want a also. This will be a cos cube theta 2/3, a sin cube theta 2/3. Let us take a to the power 2/3, a to the power 2/3 outside. This will be cos square theta plus sin square theta, because only 2 remains, 3 gets cancelled out. Cos square theta plus sin square theta is 1. So this will be a to the power 2/3. Now we have just got x 2/3 plus y 2/3 as a 2/3. So now we can have x as a cos cube theta and y a sin cube theta. So now our process starts from this point. So we'll find dx by d theta and dy by d theta, and we'll divide dy by d theta by dx by d theta. Dx by d theta is what? 3 minus 3a cos square theta sin theta, and dy by d theta is 3a sin square theta cos theta. You know how to differentiate these two. So dy by d theta will be this divided by this, and you get this as dy by dx, which is the things gets cancelled out, 3a cancelled out, minus will remain, and this sin gets cancelled by sin, and this cos by cos. Sin by cos is tan, and tan was what? Tan theta was what? See, tan theta is nothing but if you divide these two, means a sin cube theta by a cos cube theta. If you say this is y by x, it cancels out, and this is tan square theta, y by x. So tan theta will be y by x under root. So this is you get. This is the cube root. I'm so sorry. This is the cube root, because this is cube root. This is cube root. So this is cube. This will be third root.